find, respectively, the equation of a wave traveling along the S direction is given as this. Determine the amplitude, frequency, angular frequency, wavelength, and wave speed. So we've got a lot of parameters to look for. So without wasting time, let's just quickly write and start taking them one at a time. So we bring out this. We bring out this. I have 1 is equal to 0.25 times 10 raised to the power minus 3, bracket open, 500t minus, this is minus sign, 0.025, 25x. I need to redo this. So that to accommodate enough space, right? So we have y is equal to 0.25 times 10 raised to the power minus 3. Then sine, bracket open, we have 500t, that's this, okay? And then minus 0.025, I still have the same thing here, alright, x. That's the equation of a plane progressive wave. Now we need to state the general equation that we're going to use to solve this. And that is given as y is equal to a sine, bracket open, 2 pi ft minus 2 pi x all over wavelength, bracket close. This is exactly full representation of a plane wave profile. Now, to solve this and find all these parameters, we need to apply comparison method. Yes, we need to apply comparison method. And how do we mean by that? We compare parameter wise. What we have here, whatever we have here is the answer, and then we compare that way, and so on and so forth. So for us to find, the question says determine I, this is I, the amplitude. It means this is the position of the amplitude. So any number here represents the amplitude. Therefore, I, the amplitude A, is given as 0.25 times 10 raised to power minus 3 meters. So the amplitude has been determined. We have found this. The next one is frequency. How do we find frequency? It's very simple. This is the frequency. This is the part that contains the frequency. And then we're going to compare with this. So we bring it out. 2 pi ft is equal to 500t. Alright? You can see there is t here and there's also t there. We cancel out. And we're left with just 2 pi f also 500. So we make f the subject here. It becomes 2 pi. It becomes, that means we're dividing through by 2 pi. And then here 2 pi. Then frequency f is now 500 all over 2 pi, okay? That's it measured in hertz. Okay? This is the value of the frequency. 500 over 2 pi measured in hertz. The SI unit of frequency is hertz. Then you can simplify further here by substituting the value of pi, multiplying by 2, then 500 with divide all that you have there, whatever it gives you, still remains the value of the frequency measured in hertz. So this has been found, this has been found. The next one is the angular. The angular velocity or angular frequency, so to say. Angular frequency is given as Wt, okay, is the angular frequency. And we're going to compare with this. Okay? We're going to compare with this because this is where we have the angular frequency, which is given as 2 pi ft. It means that this 2 pi represents this, which is 2 pi f, alright? So we can now say, in place of this, we have this. We can now say that WT, the angular frequency, is equal to 500 T. Alright? Okay, with this, we can simply find the angular frequency. By cancelling out T, we cancel T, I will have angular frequency is equal to 500 radian per second. Radian per second, okay? Alright, so we found the angular frequency. We take that, solved. The next one we're going to look for is wavelength. Wavelength this side. We compare this side with this side, and we have, first of all, we pull out this minus 2 pi x over wavelength is equal to minus 0 point, that is 0.25x, all over 1. It is all over 1 because to balance both sides fractionally, we fractionize both sides, okay? And that means cancel minus, we cancel minus here. Cancel x, we cancel x here. And the remaining part is just 2 pi. 2 pi over wavelength is equal to 0.025. So what do? We make the wavelength lambda the subject, and it becomes wavelength is equal to 0.025, alright, all over 2 pi. And wavelength is measured in meters. Simple. So that is it. Further simplification, 2 times the value of pi